Okay, here we're standing beside the stem of the Daisy wind generator. Here you can see a mock-up of an alternator clamped onto a brake on a hub. The hub's a standard Vauxhall Meriva hub. Here's an alloy wheel with the back end cut off. This enlarged brake disc is probably going to be a pulley in the final model. So what this is, it's a wind generator, power generator. You have an inflated ring with a bunch of kites tied around the outside of the inflated ring. I've made a proof of concept and the thing whirled around quite well. I've improved this version by tying the back end, the back midpoint of some of the kites up to the leading edge of the following kite as it spins around clockwise. This should improve stability. There was a wee problem before with kites collapsing. They managed to sort themselves out as it would spin around. The air inside would be centripetally accelerated to pull the kite outwards. The kite does tend to want to stay out, so that's good. From the wheel we have some lines holding the ring as the ring goes round, so that keeps the tension in the system, which allows torque to pull the wheel around. You've also got the back lines, which are slightly elasticated. There's bungee on these. The dark patch here is bungee. There's bungee on these lines, which allows the back of the kite, as the wind picks up too much, if too much force is on the wing, it should allow the wings to fold out backwards, therefore dumping power, getting rid of power as the thing takes more load. Now, this modification over my earlier designs, I've got this stem bolted onto the ground, basically a piece of field drain. As the wind blows the kite about, it leans away from the wind. Much simpler than your average, certainly than your average windmill mount, but much simpler than the mast construction I had for the earlier tests. And here on the earlier tests I didn't have all the generation system and ability to take torque out, but now I've opened up the connector and put it on a hub. I'll be able to take torque out. On the back of the kite you've got a small hub, and we're going then up to the lifter kite and the control system. So here's the lifter kite at the top, just standard ram air lifting kite, 3 lines, and you've got 2 back lines which control your steering. So you pull on this one, comes over this way, pull on that one, goes over that way, and 1 front connection point. In this mock-up I've got here, it's a very stable setup. I've drawn that's slightly out, that should be more in line. You've got the front line, and the difference in power the difference in tension between the front line and the back lines gives you the angle of attack of the kite. So if we pull the back lines downwards, the kite has a greater angle of attack and tends to rise upward in the sky. It creates more of a wedge against the wind basically, and pulls itself up, pulls the whole line set up to a higher elevation. If you let the back lines go, the kite flattens off and the whole set comes down a wee bit. Now, controlling that motion, you have this device here which controls the 2 back lines at the same time by sliding up and down this sling below the main line. So as this whole gadget goes up here, the back lines together get fed out. As it comes down, the back lines tighten up and the whole kite lifts a wee bit more. That's run by these 2 pulleys mounted on to 1 pulley going forwards, 1 pulley going backwards, controlled by a single servo. As the servo goes, let's see, clockwise, the whole set will come backwards. there'll be a greater angle of attack. As it goes anti-clockwise, the whole set goes up the line, meaning that the kite loosens its angle of attack and floats down a wee bit. So you can basically set the elevation with this over here, with a servo on the bottom. A very similar setup. One servo controls two pulleys, which winds in and out, and that's controlling just the back lines. And you're controlling the tension difference between the two back lines. So if you pull on this side but let this side go, I'll explain that a wee bit more. You've got 5 windings anti-clockwise on one pulley, 5 windings clockwise on the other pulley. As you turn them both one way on the one servo on one shaft, you release tension on one side, pull a bit of tension on the other side. That rope's a bit fat in this rendering. I'll have to work on that. And as you do that, you pull one side, release the other side, you'll steer the kite left and right. So you can set the kite with a standard remote control for elevation and left and right. You want to set it to trim it so that everything's balanced in here. So you've got an elevation that agrees with setting the angle into the wind of the disc here, and you want to keep as close to downwind as you can. The test we did before, we were 20 degrees off downwind, and the kite still seemed to be spinning around okay, so you've got a fair degree of control in there. Now the aim of all this, of course, apart from saving the world and giving everyone cheap energy, is the aim of this project is hopefully to be able to extend out in a line and extend outwards the radius of the ring out to, you know, hundreds of meters, kilometers eventually, hopefully. We want to extend numbers of rings out along the line. The more you'd put out, assuming they fly together well, more power you'll be able to take off of the joining them in a shaft type way. Yippee. It's very exciting for me anyway. Now more technical detail. Let's see, we've got the straps going around the ring here. I've got Netty Zapata making me a bag for this ring. Sorry, I'll just get that turned around so I can see it. And that inflated ring was all we had on the first test, but I've now been contacted by Jim Haddocks at kitebladder.com. He's offering to make me some bladders, and between himself and myself and Netty, we'll be able to create bags for these bladders, encompassing the inflated component, making a rigid structure that we can tie off onto. So with webbing, I'm going to get some just standard kites and set them onto this bag. Sorry, the drawing's quite unwieldy when it's this big. I don't think you make it. I'll attach webbing along the bottom of standard kites onto straps around the bag, and you can set the angle of attack of these kites into the rotation. Notice how the back lines are set further advanced clockwise around the wheel than the back lines are set onto the inflated ring. This gives your tip pitch as it's going faster around, as the outside is spinning faster, your tip is pitched to meet that apparent wind just that much more neatly as it's tilted around clockwise. There's a twist in your wingtip, like any standard propeller basically, as that point out here is travelling faster with a relative wind. It's had a lot of response online. I've spent a lot of time with the likes of the Yahoo Airborne Wind Energy Group. People on there such as Dave Santos, Doug Selsom, Joe Faust, Peter Lynn. They've all given me some very positive and encouraging feedback and a lot of help from these guys. Hugh Piggott from Scottish Wind, he's been remarkably helpful. Many others have helped out and given suggestions and designs along the way. Thanks to everyone. So yeah, this is keeping open source, this project so far. Yeah, I'll hope to develop it, and I'll certainly release plans for this lot open source as I can.